there's multiple facets to it. So one is the philosophy of science, which is what you were talking about first, which is just that this is the way we do science. You come up with a hypothesis, and then you work out a way of testing that hypothesis, and you want to falsify that hypothesis by doing good experiments, and then you have ways of analyzing that data which vary greatly, and then you come up with a conclusion based on the results, based on the analysis that you did. And that hasn't changed for a while. I mean, that's not the way we always did science, but that's the way we've been doing science for the last 150 years, 200 years, which is still the way we do science. The problem is that on top of that, you've got humans, and it is a human endeavor, science, and humans all come into that endeavor with their with biases, and those biases are because of the fact that we don't perceive the world as it actually is. We perceive the world based on what we call predictive coding. So our brains create this illusion of what we're actually seeing, and that illusion is based on our memory, our long-term memory, which then checks whether or not it is correct. So a good example of that is just speaking. Like when I speak to you, my voice box moves, which creates a wave in the air, and that then moves your eardrum and moves a couple of bones and moves another little eardrum and moves your cochlea, which then hits little hair cells up against the membrane, which causes activity in your brain, and then your brain creates an illusion that you're hearing sound, you're hearing my voice, but there isn't any noise in the world. There's simply air being vibrated in the world. And so our brain is creating this illusion of the words or of the sound. And all of our senses and the world that we see is based on these illusions that our brain is creating, which we've evolved to enable us to live in the world that we live, which means that we don't have any veridical perception of what's actually out there. So even when you look at something and you try to take a measurement, you don't have veridical perception of that measurement. It's an assumption based on what you're actually putting into your brain and based on your previous experiences. Yeah. So I might do an experiment and see one thing from the results of that based on my prior experiences, whereas somebody else might do an experiment and see something different based on that, based on their experiences. And so being a human endeavor means that there's always going to be some of that extra in there. We've also got the problem of how do you measure anything and then how do you analyze it? And so there's so many different ways. My area of expertise has always been neuroimaging, taking images of humans' brains while they're doing things using different techniques and then working out how their brains actually work. But there's probably, I don't know, if you look at it, there's probably 100 different ways that you could analyze that data. And each of those ways could probably come up with different results. And you've got to work out what the best way is. And so two different scientists could get exactly the same experiment with exactly the same data and then analyze it differently and come up with different results. So there's lots of aspects to the way we do science that is going to mean that the results are going to come out slightly differently based on our experiences, based on where we're going. But it's also, we have the problem now that in science, it really is a publish or perish sort of phenomenon. So you've got to be constantly publishing to get grants and to keep your job and to keep getting promoted and to keep getting students and all these things. And so you've got to be publishing a ridiculous amount. I remember seeing some stats that I think it was like 30 years ago, most scientists would publish, one paper every 2 years. Now scientists on average are publishing 5 to 6 papers every year. And to actually do that, you've got to be pumping out a huge amount, but it means that you don't have the time to actually check that it's all been done properly and it's all been done really well. And so we've got to somehow change that so that we don't have this really big emphasis on scientists constantly publishing, because the work isn't as good when you're doing that. And then if you think back to like Galileo times and all that, right, they probably publish one paper a year. And so we're trying to pump out too much now, which means that the results often aren't as reliable as they used to be because of that, because we're constantly, and so there's errors being made. But then also, I think the public don't realize that science isn't about coming up with the answer. Science is about getting closer to the answer. So we never actually come up with the truth, right? The only, which I love the quote, I forget who said the quote, but the only science where you can prove anything is mathematics, because mathematics you can come up with proofs. But every other science, there's no proving anything. All you're doing is trying to get closer to the truth. And so that's where we are. And I think that gets missed a lot in the media, and it gets missed a lot by the public, that we're never actually proving anything. What we're doing is we're getting closer, hopefully getting closer to the truth every time we do an experiment. We're not actually, at the end. So it means that there are going to be lots of times when, scientific studies are wrong. And we shouldn't be beating up the scientists because of that. And we shouldn't be throwing out all science because of that. We should just realize that we've got to look at, the whole gamut of it and go, what's the trends here? Where are the trends showing us? Which is why, whenever I present stuff on, devices or on the brain or any of these things, I look at both my research, but everyone else's research to work out what are most people showing? What are most people, actually in this area? And if 95% of people, the scientists, are showing these effects, then I'm like much more confident. Whereas if one scientist shows it, then I'm not that confident. And there's another, so I'm going to come up with another. I told you we could do this for hours. There's another problem, is that the high impact journals, the ones that the media actually like to cite from, like Nature and Science and these journals, they only publish stuff which is really unique, which is one-offs, which is way out there. They come up with this brand new, wow, look at what we just found. But the problem is they're the least reliable of the results, yet they're the ones that get into the media. And once they're in the media, everyone talks about them and everyone's like, oh, wow, da, 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 da. And so and then other scientists will come up with a bunch of research showing, no, that's not true. But that'll never get into the media because that'll be published in lower impact journals, because these high impact journals don't want to hear about that because it's not new and it's not fancy, right? It's just showing that wasn't right. So I figure there was a study showing something like 90% of the papers that are published in these high impact journals are actually not replicable. They're not actually true. They're not actually coming up with real results. Yet they're the ones that get all the media attention. And they're the ones that the scientists actually are more likely to get the next grant and are more likely to get a good job because they're published in those high impact journals. But the results in those high impact journals aren't great. So there's a few issues for you. I'm not sure how we solve any of this. There are some great people working on some of the solutions to it. Making everything open access and these sorts of things could help. But I think science is wonderful, and science is what got us to where we are today. And science, I think, will keep going into the future. I think we've had a bit of a blip in relation to the way media handle science and the way the public sees science, but hopefully we'll flip back and start realizing that science is cool. I love science.